Turn any image into a 3D model in ComfyUI on your own computer for free. This is TRELLIS.2, Microsoft's open-weight image to 3D model. No cloud, no modeling skills, no subscriptions.
TRELLIS.2 is a 4 billion parameter model that takes one photo and builds a fully textured 3D mesh with PBR materials, base color, metallic, roughness, even transparency.
It handles complex shapes other methods fail at, and it exports GLB, FBX, OBJ, and STL. Print it, put it in a game, drop it into Blender. The circuit is tiny. Load image, generate the mesh, bake the texture, export.
One photo in, a real 3D asset out.
Here is what you need. An NVIDIA GPU with 8GB of VRAM. That is our target. About 17.5 GB of free disk space for the model files. The latest stable ComfyUI.
And a clean reference image. A centered object on a plain background works best.
First, install the node pack. Inside your ComfyUI folder, open custom_nodes. Click the address bar, type CMD, and press Enter. A terminal opens right here. Run git clone, paste the visualbruno TRELLIS.2 repository link, and wait for it to download.
That folder is your node pack.
TRELLIS.2 needs 5 CUDA libraries, and the pack ships pre-built Windows wheels for them. Run each one with the embedded Python exactly like this. QMesh, NVDiffRast, NVDiffRack, FlexGem, OVoxel.
Each print successfully installed. And here is a pro tip. The loader's default attention backend is flash attention, but you can switch it to SDPA and skip that wheel entirely.
Next, install the Python dependencies. One command, pip install -r requirements.txt. It pulls pmeshlab for mesh processing, Open3D, OpenCV, reambg for background removal, and a few helpers. If you see the pmeshlab error later, this is the step that fixes it.
Restart ComfyUI and wait for it to boot. The console shows the TRELLIS.2 nodes imported. Back in the browser, right-click the canvas, search for Trellis, and every node should appear without a red background. Red means a wheel is missing.
Now load the ready-made workflow. In the node pack folder, open example_workflows and drag mesh with texturing.json onto the canvas.
Here is the circuit. Load your image, pre-process it, generate the mesh, sparse structure, then shape at 512, refine to 1024, clean it up, bake the texture, and export. 6 jobs, 1 photo.
Hit Q. The first run downloads everything automatically. The console prints downloading Model 2, followed by the path, then pulls about 16 GB of weights, plus the DINOv3 image encoder. This takes a while. Do not close the terminal.
If you interrupt it halfway, the download cache corrupts and you get the repo ID error, just delete the partial model folder and run again patiently.
Watch the pipeline work. Spare structure first, then the shape flow at 512, refined to 1024, then the texture pass bakes the materials from your photo. Progress bars fill stage by stage.
When it finishes, the preview panel opens a live 3D viewport, drag to orbit. That is your photo, now a rotating textured 3D model.
Export it. The export node writes a GLB file into your output folder. Drag it into Windows 3D Viewer or Blender, and it opens as a real mesh. Change the format to STL for 3D printing or FBX for game engines.
One file, every format.
And yes, 8 GB is enough. In the loader, keep low VRAM mode on. It defaults to true, and start with the 512 pipeline.
On an RTX 3060, that is about 6.5 GB of VRAM at around a minute per model. The 1024 Cascade fits too, with low VRAM mode, around 7.8 GB.
Full 1024 plus a 2048 texture is happiest on 16 GB. Be honest with yourself about quality versus time.
3 errors to know. 1. Repo ID must use alphanumeric characters, that is a half-finished download. Delete the model folder and retry.
2. A DINOv3 size mismatch. CLS token 1024 versus 384. That is the wrong or partial image encoder. Let the node download the full files.
3. Wheels failing with an undefined symbol, your Torch version does not match the pre-built wheels. Use Torch 2.8 and install with no dash deps, so pip never rebuilds them from source.
Here is the payoff. Generate a consistent character with the LoRa from the earlier episodes, run it through TRELLIS.2, and your character becomes a printable, importable 3D asset.
Product shots, game props, concept art. All free, all local, all on 8 gigabytes.
Recap: install the node pack, install the 5 wheels, load the workflow, wait for the download, generate, and export. TRELLIS.2 is MIT licensed, so you can even use it commercially. If this helped, like, subscribe, and comment. Happy generating.